As we discuss the trophic state of lakes, we have to think first, what does the word trophic mean? And we're talking about trophy, feeding. So people may think about a trophy animal like a big deer or a big fish. That comes from an old term where a person would shoot the animal and all the people would celebrate because they had food to eat. So the word trophic comes from trophy. And when we're talking about trophic, we're talking about feeding. And how do we determine whether a lake is mesotrophic or eutrophic? Is it doing a lot of feeding? Is it, or is it doing a little? How do we do that? So the most common one is to use Carlson's Trophic State Index. There are other indexes out there, other indices out there. Carlson evaluates Trophic State Index first by using chlorophyll A, which is the best measure of primary productivity. In its absence, we can also use total phosphorus or Secchi depth. Trophic State Index is not necessarily an index of like the safety of the water, but rather just the condition at which the lake is operating with respect to its feeding and how it's kind of maybe going through lake succession, because we know that eutrophic lakes are more likely to fill in and burn out or end their life more quickly. So Carlson evaluates the Trophic State Index using also total phosphorus and Secchi depth as an alternative to chlorophyll A. And some people have taken Carlson's index and modified it, and they have developed one for also using nitrogen or nitrate. Carlson will tell you that Secchi depth is the easiest one. Not just Carlson, anybody will tell you that Secchi depth is easy to do. The reason why I mention him is because he does the big dip, or the Great Dip In, or whatever the event was called, where, and I think it still goes on, where students and environmental groups can annually check the health of their lakes, but in terms of whether or not they're filling in or not, whether they're going through eutrophication at a faster rate or not, by lowering this disc into the water and measuring the transparency. Doesn't require any meters or anything, just the ability to get out on the water and lower it down deep enough. The Trophic State Index, it can go lower than 20 and it can go higher than 80. Higher trophic scores are associated with more eutrophication, hyper-eutrophication. Oligotrophic have low Trophic State Index scores. So we can measure the Trophic State Index as a proxy using the Secchi depth. And there are formulas in Carlson's 1977 paper that you can refer to. With respect to transparency, a lake like Lake Reba or Will Green Lake, sometimes we can only see 50 centimeters down or 33 centimeters down. Half a meter, a third of a meter. So half a meter is about 1.5 feet. 1.6 meters, about 3 feet. So half a meter down, that's all you can see. That puts those lakes typically, based on Secchi depth, in the hyper-eutrophic condition. Other lakes like Laurel Lake, that's just south of here, has a lot of national forest as its kind of watershed. Very few nutrients or low concentrations of nitrogen and phosphorus get into the lake. So it tends to be more like 5 or 4 on transparency. You can see down 15 feet or more. So there are other lakes like in eastern Kentucky, Grayson Lake, you can see pretty far down into the lake. The state used to actually add fertilizer trying to increase eutrophication with the hope that they could potentially increase fish production. Chlorophyll A is what is the probably best measure of primary productivity, but it does require a bit more steps. You have to filter the water. You have to then break down the filter to do it properly. This is extracted chlorophyll A. Then you use the acetone extraction method to measure the chlorophyll A with a fluorometer. And high chlorophyll A concentrations in the water mean more likely to be hypereutrophic. Also, high phosphorus levels correspond often with chlorophyll A in phosphorus-limited systems. So you can measure phosphorus as well as an indicator of the trophic condition of the lake. So those are just some helpful pointers on how you can approximate the trophic state of a lake just with any one of those variables. You should not measure them individually and then average them. They each speak for themselves, and the trophic state index is not a measure of the safety of the water or the quality of the water. Carlson would disagree with it being used for that. However, as a person who studies harmful algal blooms, I'll tell you that as you have more chlorophyll A or more phosphorus in the water, sometimes we get more anxious about the water quality with respect to its ability to produce algal blooms and have fish kills. Harmful algal blooms are harmful because of the monetary impacts, the impacts on tourism, the impacts on fishing, the impacts potentially on health, the concerns about the taste of the drinking water, more disinfection byproducts. So although they're not truly individually health and safety measures, there are other measures that are better for health and safety. You can use this information to inform what may be causing those health indicators to become a problem. So I'm going to stop the video here, do a little review, and this will wrap up this section for your quizzes.